BGP Part 3, Foundation BGP Configuration. Okay, here we are. We've gone through two nuggets of theory and concepts about BGP, talking about really the foundations of what BGP is all about, and then getting into the attributes that you can use to tweak which direction your router goes when choosing a BGP route. We're going to get back to a lot of those when we get into the application, but before we do, I want to start off with a foundation BGP configuration. There is a lot of things that can happen just with the simple configuration of internal BGP or iBGP and eBGP neighbors. I'm going to give you some things to watch for, and I'm going to start it all off with checking your router. A few pre-thoughts on BGP configuration. We're going to take a look at some things that you might want to consider before deploying BGP in a production environment. I've seen too many cases where somebody turns on BGP to the service provider and negotiates with the service provider to get that link and crashes the internet router because it doesn't have enough resources to run BGP. So I'm going to talk a little bit about that. We'll then get directly into the configuring and troubleshooting of BGP relationships and setting up BGP peers to trade routes within and between autonomous systems. Then there is this one confusing thing, the third bullet, how to get networks advertised into BGP. This is something I've seen a lot of people do. They create the neighbor relationship, they're communicating, but then they find out, oh, well, wait a sec, I'm not actually sending that neighbor any of my internal routes, meaning nobody on the internet is able to reach any of my internal resources. Now, from a security standpoint, that's great, but if you're using BGP, the most likely reason is because you want to advertise something that's in your organization to the world so that they're able to reach it. I'm going to do a special part on how to get networks into BGP through a couple different processes. We'll then hit the plethora of show commands. We're going to do this all throughout. So there are tons of ways to verify, debug, and watch what BGP is doing as it's exchanging routes with other neighbors. Well, before we get going, I'd like to hit a few BGP pre-thoughts. Some thoughts before you start BGP running on your routers and get it up and going in a production environment. The first thing is that in order to host the complete BGP routing table, I mean the routing table of the internet, 128 megabytes of RAM is recommended. Now, it's not required, but usually when we're having a routing table that large that does consume the memory of our router, and we're sending packets through, we do need a lot of RAM. Now, it doesn't take this much memory to hold the routing table. That's why I say recommended, not required. You can actually get by with something like 64 megs. However, when you have a routing table that large and that many destinations to cache and figure out directions to, typically your router is going to consume a lot of RAM to run efficiently. So that's usually your best bet. Now, if you host like partial versions of the BGP tables, like maybe a few select routes, and we'll get into the design strategies, but you don't have to have the entire BGP routing table to succeed in connecting to the internet. If you do something like that, the amount of RAM goes down significantly depending on how many routes you do accept from your service provider. Now, there is a few disaster prevention things I want to go over with you. Is number one, if you plan on doing BGP and it's your first time, first, do it in a lab environment, and second, make sure it's the off hours of the business before you set up BGP deployment, because you may lose that router if you haven't fully tested its capabilities to run BGP. Now, with that in mind, limit the iOS features that are supported and used. And when I say disaster prevention, this will allow you to have an operating system running that is geared more towards what you're looking for in a BGP router. For instance, I wrote down here, BGP typically requires an upper-end iOS versions, meaning a lot of the times if you just get the standard IP version of the iOS, you're not going to have BGP in there. But with that in mind, there are lesser versions than the full enterprise or advanced enterprise subset of features. When you get one of those iOS versions, you're going to get the whole shebang of features, which, you know, for me, a feature nut, I'm thinking, great, I've got everything. But the more features you add to that router, it's kind of like if you're a Windows 2000 or 2003 guru, you know that the more services you have running in the background, the slower that machine performs. Same thing here. If you have a lot of iOS features that maybe you're not even using, there's still services running in the background, like IPX, AppleTalk, I mean, to support protocols that just aren't really used in many networks anymore. So grab an iOS version. If you're looking for BGP, try and get the one that just supports BGP. Sure, you're going to get some other features. However, limiting that amount instead of going with a full enterprise subset will help prevent your router from crashing because its resources are overused. Second, and this just goes to any resource consumption, disable console logging. Regardless of whether you're plugged in or not, that thing's going to start spewing messages to the console anytime something happens. And the reason I focus on it with BGP is because we typically do a lot of debug commands with BGP. Instead of having it logged to the console, go ahead and use a logging buffered command or a syslog server to log to an external server so you're not flooding your console and consuming those resources. Finally, use the scheduler allocate global configuration command. Not many people know about this one. This command allows you to allocate how many interrupts your processor will use to route network traffic, I mean the actual process of sending traffic through the router, versus handling system processes. I'd really recommend you check out Cisco's website. They have a lot of great examples on using this, primarily with ATM, but also with BGP. But it allows you to say, well, I want to, for every, we'll say 3,000 microseconds that I spend routing network traffic, I also want to spend 500 microseconds or 2,000 microseconds or whatever your ratio is actually handling system processes. That'll make sure that your router does not get overtaxed and overused by the traffic going through it and leaves no resources for itself. That can actually cause a system freeze if you have no resources available for the router processes. Now let me show you, whenever I've talked processor cycles and so on, let me show you a few commands that I use all the time in the real world to help figure out what's going on. The first one is an alias that I create on nearly every production router. Watch this. I'm going to go into global configuration mode. And what I usually do is I name this alias. It's alias exec because it's in the exec mode. I usually name this PROC. That's just my own little nickname for it, for processor cycles. And what I'm going to type in here is show processes CPU. This will focus in on the processor of the router itself. And I'm going to use a little argument here. I'm going to say exclude anything with 0.00% underscore underscore 0.00% underscore underscore 0.00%. Enter. Now you're looking at that alias and going, wow, what on earth is that? Well, I'm going to go back here and do a show processes CPU because you'll see here that it shows you all of the processes that are running on your router. Now, given there's not too much going on here, but every single process that's running on the router and how many cycles it's consuming on your processor. Now this percentage, you can see it's over 5 seconds, 1 minute, and 5-minute averages of how much it's consumed. Now if you're looking for a specific process that's consuming resources, look at all this stuff you have to weed through. You have to scroll up and down and see if you can find it. Well, I think you already have a good idea of what this command is doing. I created an alias that when I type in PROC, it will exclude everything that is not consuming any resources over 5 seconds, 1 minute, or 5 minutes. So essentially, any processes that is not currently, or within the last 5 minutes, interrupting my processor at all. So I type in PROC, hit enter, and now I see, well, this router is a lab router. You guys, yeah, I think you guys can tell this, because I only have one process that's actually consuming router resources, and that's the exec process, which is supporting everything that we're doing right now. Now, when we start getting into BGP, let me show this. I'm going to start the BGP process. I'll type in router BGP, just autonomous system 1 for now. I just started up the BGP process. I'm going to type in show processes CPU and add an argument in there. I'll put include BGP. This will include all of the processes that do have BGP in them, so I can focus in and see what BGP resources are currently being consumed. Now this is case sensitive, so make sure you type in all uppercase. Now we see 4 here right now. There will be, or I'm sorry, 3 here right now, but there will be 4 when we get into the full configuration and maintaining neighbor relationships. I just want to talk about what each one of these does. So when you see them, you'll go, oh, okay, that's what that process is doing. That's why it's consuming so many resources right now. The BGP router process establishes all your peer sessions. So anytime you have a new neighbor, that process will handle the actual establishment of the peer sessions and making sure that that peer relationship, the neighbor relationship, comes up and is running. Now the BGP IO, this one is used to process all the packets that are coming in for BGP and queue any of the BGP update or keep alive messages. So if you have packets that you're sending out or receiving, this is the one that's probably doing it. And it will maintain your neighbor relationships, doing those keep alive messages. Now BGP scanner runs around the BGP tree, which is the entire BGP routing table. It goes up and down looking at it every 60 seconds to make sure that the next hop hasn't changed, to make sure that we have the most efficient routes plugged into our routing table. And the scanner kind of gives you that feel. You know, when I think scanner, I think of these movies where we're kind of, you know, futuristic movies where we're scanning the data, going back and forth to find the most efficient way out. That's what BGP does with its scanner process. Now, one is missing, and it's for good reason. When you start BGP neighbor relationships and we actually start typing in neighbor command, you'll see one at the very top called BGP open, and this will establish the TCP session between the BGP peers. That's its sole process. So if you're starting new neighbor relationships, you'll see BGP open kick up quite a bit on the processor usage until all those neighbors are established. Then we'll see the BGP router and the BGP IO just have a minor processor usage that handles the keep alives to keep those neighbor relationships running. Those are very cool to find out what is going on with your router. Now, if your concern is memory, you can use the same command and type in show processes memory, and you can see how much memory each one of these is consuming. And let me do it without the argument so we can get all of the fields up here, but you can see how much allocated, free, and holding memory each one of those processes running. That's just, it kind of goes into the pre-thoughts and it kind of gets into the configuration a little bit, but I just wanted to just show you how you can track how much processor and memory usage BGP is consuming on your router, because in a production router, it can go up quite a bit depending on the router platform that you're using. If you plan on running a full BGP routing table, I would recommend at a bare minimum a 2600 or a 2600 XM router decked out with memory. So with that in mind, let's get into the BGP configuration. And I want to walk you through the steps to configure BGP sessions between these peers, and then we'll start getting our autonomous systems, our networks advertised into the BGP routing process. You can see I have router 1, router 2, and router 3. I kept all the masks at 24 for 24 bits for simplicity's sake. Ethernet connection 172.16.12, and WAN connections 192.16.203 and 192.16.23. I'm also going to show you how you can start load balancing and using redundant links using BGP. So let me bring up the command prompt. And I'm sitting on router 1 right here. The first thing that I always do before I get going with any BGP configuration is ping the other side. I don't know how many times I set up BGP and I'm thinking, oh, it's not working, and I find out, oh, some kind of physical connectivity or encapsulation has caused my failure. So right there I have connectivity to the other side. Let me get back to the diagram. This is Autonomous System 605. So we go into global configuration mode and type in router BGP 605. Enter. As soon as we do that, we've started the BGP routing process, and it's now running for that autonomous system in the background. We can do all the show commands that I showed you before to verify the processor resources, the memory resources that are being consumed on this router. But I want to set up our first neighbor relationship. You'll find most commands in BGP start with neighbor. So I'm going to say the neighbor that I'm speaking to is 172.16.12.2. That's router 2. And you can see when I hit question mark, I have a whole host of options, and we'll get into a lot of these, especially in the more advanced BGP nuggets. The first option that you always type is remote AS, because you need to specify what remote autonomous system this neighbor is in. And looking, I see that this neighbor is also an Autonomous System 605. Now, since I started my BGP process with 605, as soon as I type in remote AS 605, it's going to go, oh, you're using iBGP. It's an iBGP session. Now, that's my first neighbor relationship, and the other side's not configured, so it's not going to be successful yet. Let me do one of my favorite commands. I would suggest you create an alias for it on your production equipment or your CCIE lab environment. I'm going to do a show IP BGP summary. That shows me what the status is, just a summary status of my neighbor relationships. Yes, there is a show IPBGP neighbor command. However, it gets excessive with the amount of information it gives you, and that's not usually useful most of the time. You see, this is the only neighbor I've specified, the version number of BGP, the autonomous systems, the facts about what's been sent and received and what's waiting to be sent and received in the queue to that neighbor. It's never been up in this case because we haven't configured the other side. So what we see is the state is idle. And if we do the command again, you'll see always cycling between idle and active. When you see active, the instinct is, ooh, wow, active neighbor, that's good. No, active is bad. Active means it's actively trying to form that neighbor relationship. And if we keep hitting that up arrow, we'll see it go between idle and active because it's going to try, fail, and then go back to idle, then try again and keep that cycle going. We can also do this command, not many people know this one, show TCP brief all. This shows the TCP sessions that are established or are listening for on your router. This is from the router itself. If you look right here, the local address, and by the way, the format it uses is IP address dot and then a port number. So we see right here it's saying from any address on port 179, I'm listening. On any address on port 80, I'm listening because this router has the HTTP web server feature enabled on here. So it's listening for web requests, and TCP port 179 is BGP. So that's one way that we can verify that our router is configured to receive BGP requests. You firewall admins, definitely make sure you open that port 179. I'm going to jump on over to router 2. Let me clear the screen so I can get all the gibberish off and do the mirrored configuration on router 2. I'm going to get into global config, router BGP 605, and I'll do neighbor 172.16.12.4 or 12.1 remote autonomous system 605. Enter. I'll jump back and do a show IP BGP summary, and the key with BGP is patience. Patience, patience, patience. Now, I just hit the up arrow and did it twice, and you can see that it just now went to an established state. But you notice I typed it in, I got back out, did a show IP BGP summary, and it was still an idle. I have seen it stay this way for up to 60 seconds. I kid you not. Even though everything is configured perfectly, BGP will sit there in an idle or an active state for 60 seconds maximum. That's the longest I've seen it when forming a neighbor relationship. The reason I emphasize this and I bring it up is because BGP is a very slow routing protocol. It's designed that way because if you had a fast routing protocol on a network the size of the internet, you would have network update chaos going all around. And I can't tell you how many times I've been setting up BGP, I get here and I go, oh, it's idle. Oh no, and I go, my config's wrong. I wipe out the autonomous system, I reconfigure BGP and look and it's idle again. Oh no, and I go through this whole troubleshooting mess. When really, if I would have just waited another 5 seconds, it probably would have established. Now we can see that we have an established state for 1 minute and 6 seconds with our BGP neighbor. Now you see the state here is 0. It says state/prefix received. That's a good thing. Back in the BGP theory nugget, we talked about all the different states, the open, idle, open, confirm, open, and we went through all the different states that are out there. If you're fast enough, you'll see some of those take place. However, what we want to see is a 0. And if we do the show IP BGP neighbor command, you'll see in this case, the state is actually established. This 0 is what prefix we've received. And there's the other side of the coin. I've set up BGP, and you can see why I don't use the neighbor command. So much stuff. I've set up BGP, but I haven't received any prefixes, or I haven't received any updates from my neighbors. If I do a show IP BGP, which shows me the routing table for BGP, You notice, nothing there. It comes back empty because by default we can create these neighbor relationships but not send any routes. You have to manually tell BGP what routes should be advertised into that routing table. I'm going to do a show TCP brief all and show you the TCP sessions, and right here you see that TCP BGP session from the other peer. It's incoming on port 179, that's the TCP port, from the source port of 11,005, which is just a dynamically generated port. And you can see that this router is still listening on port 179 for any other incoming requests as well. So it's still ready to receive other routers that are coming in. Now, before I get into the advertising of networks, what I want to do is I want to show you the communication with BGP neighbor establishments and neighbor relationships across wide area networks. And not just wide area networks, but wide area networks over autonomous system boundaries. And not just wide area networks over autonomous system boundaries, but using those as redundant connections, peering with a loopback interface behind one of these routers to establish the BGP neighbor relationships for redundancy's sake. So the first thing that I need to do when setting up these neighbors is create those loopback interfaces. I'm going to hop on over here to router 2, get into global config mode, and type in interface loopback 0. I'll go ahead and give an IP address of 2.2.2.2 with the subnet mask of all 255s. What that subnet mask does is say, I'm just assigning that IP address. I don't want to kill an entire Class A network just to give a loopback interface an address. This says it's only this address on this interface. It's not the entire Class A range. I'll jump on over to router 3, do the similar thing over there, interface loopback 0, IP address 3.3.3.3. So I've now given each one of these routers their own loopback interface that I'm going to create a BGP peer to. Here's the concept. Router 2 has the loopback interface that I just jotted down, and here's router 3's 3.3.3.3. I'm going to have the BGP neighbor sessions peer with those interfaces. That way, this land in between, these dual WAN connections, isn't really seen by BGP. It's just kind of transparent. It just knows that it uses those to get to that interface on the other side. So we can implement any type of load balancing function between those two interfaces that we want to. Now there's a few ways that we can have router 2 know, oh, I put a little slash on it, router 2 know about this interface behind the scenes. As of right now, router 2 can't reach this interface and vice versa. We could go on router 2 and create dual static routes, and we could say to reach the all 3 interface, use this and this IP address. As long as both those static routes had the same administrative distance, it would go ahead and start load balancing between them. Now, you and I both know on the CCIE lab exam, static routes are typically a faux pas. You can't do them. So we may have to rely on a routing protocol to advertise those for us as well. And whatever routing protocol load balancing functions are out there, it will be able to implement. So if you're in the CCIE lab, you'll use whatever protocol they tell you to use, or if you're in the real world, we can use, well, whatever protocol we're using in our environment. I'm going to start with router 2, and I'm going to use EIGRP. I'll go ahead and create it for autonomous system 1, and I want to type in network 192.16.23.0. I'll do 203.0, which are the two interfaces that are connecting to the wide area network. Now I'm also going to type in network, since I'm on router 2, I'll do the all 2 network. It's a class A, and I'm going to turn off auto summarization so none of that magic is going to happen, and again, kill that class A address for us. So it'll still be a 32-bit address that I have out there. And let me go do the other side, router 3, router EIGRP1, and I'll just cut and paste this one, 23.0 and 203.0. And now I'm going to type in network 3.0.0.0. Now in some recent iOS versions, you might have one that lets you type in the wildcard bits, and you get warm fuzzies if you do that, because it lets you specify exactly what interface or what network, whoa, I'm getting a lot of status messages here, what interface and what network you want to advertise on and also include in your updates. So just glancing at those updates, I should have the information in here on how to reach those two networks. And you can see through EIGRP, I have the 2.2.2 interface, and voila, we are load balancing between those two. So EIGRP has seen these two and is now load balancing between them. So we've got the foundation laid. Let's do BGP. Going to get into router 3. And I'm going to go into router BGP. Now in router 3, we are in autonomous system 7777, or one less sevens on those. So autonomous system 777, and I'm going to type in neighbor, and let's get their IP address. Who is it? 2.2.2.2. So I have that neighbor, and I'll type in remote AS 605. That is the remote autonomous system of router 2. Now I'm also going to hop over to router 2 and do the similar thing. And it's going to know it's an eBGP relationship because the autonomous system is different from what we're pairing with. You see router 2 has the local autonomous system 605. So I'm going to type in, well, let me save myself a little typing. Neighbor, I'll go ahead and change this around, 777. And instead of all 2s, I'll have 3.3.3.3. And I should have done a show IP route just, for consistency's sake, make sure that we know about 3.3.3.3 and we're able to reach it through that interface. So let me do a show IP BGP summary. What we see is that we have neighbor 3.3.3 and it is currently idle. Now I know I told you to be patient and sometimes these things take time, but I can tell you right now this will never work. And the reason why is anytime you have eBGP relationships, they must be by default directly connected. In essence, on router 2, I had to type in neighbor and some directly connected interface. So it would expect something from 192.1.6 to create that neighbor peer, but we're actually doing it for a system that's almost one hop away. I know it's connected to the same router, but we have to go through that router to reach that interface. So on eBGP relationships, which is what we have here, that is not allowed by default. On iBGP relationship, it is. You can have routers, hundreds, thousands, millions of routers if you had them, in between these two routers, and they would be able to form a relationship directly without any problems. eBGP, we have to add a little tweak. And I'll just hit the up arrow just to make sure that you see it's not being established. We have to go into that router configuration mode for BGP. And I'm going to type in neighbor. I'll just hit the up arrow actually. We have 3.3.3.3, and then we have to use a special command called eBGP multi-hop. See it right there. It says allow that's a tough one to say. eBGP neighbors on not on directly connected networks. I'm going to type in eBGP, I'll say the E word, multi-hop, and the maximum hop count. And this is going to be how many hops away is that neighbor. Now some people like to say, well, I'm just going to say 255 because, if it ever does go further away, I don't have to adjust this. But for my sake and consistency's sake, I always do exactly how many hops away it is. In this case, it's 2 hops away, maximum. It's going through a router that's 1 hop, so essentially it is only 1 hop away, but I'll type in 2 just to give me 1 extra. Yes, I know I just contradicted myself. I'm going to type in router BGP 777, and we could type in eBGP multi-hop 1 to give us that extra hop, but I'm going to use 2 in this case, just to keep it the same between both my neighbors. So I now have those neighbor relationships. I've typed in the eBGP multi-hop. Now this is again going to be where I say be patient. Show IP BGP summary, and let's see if that neighbor relationship has come up yet. Not yet. It's currently in the active state. So I should expect to see this neighbor go reachable or change to a prefix of 0 in just a moment. As soon as, I just keep hitting the up arrow, as soon as those neighbors negotiate that relationship. So I'm going to go ahead and pause the recording, wait for that to happen, and then I'll bring it back live. Oh, I hate it when that happens. It only took me a couple up arrows to realize, wait a sec, something's missing here. Let's take a look at this running configuration. I'm going to do a show run on this router 3 because there's one missing piece. We've got our loopback 0 interface. It's pingable. You can reach it on the other side. We've got our BGP configuration. We've said neighbor 2222. However, there's one piece that we are missing under the BGP configuration. When we're talking about communicating with our neighbor on both sides, I'm going to type in router BGP 777.
and I'll type in neighbor, for that neighbor 2.2.2.2, we're missing one piece, and that is going to be the update source. As in, we don't know what interface is going to be used as the from. See, here's the idea. Up here, and get back up to that running configuration. Up here, we said eBGP multi-hop. We told it had to go multiple hops. We told the remote autonomous system, but we did not tell it, hey, when you're talking to this neighbor, use that loopback interface that we set up, loopback 0, right up here, as your update source. So here's the idea. When it's sourcing the packets, it's sourcing them from a serial interface IP address. So when it gets to the other side and it's going, let's see what neighbor this matches. Well, wait a sec. There's no neighbor that uses that IP address. So we need to say update source loopback and then the number that we're going to use, which is loopback 0. I'll go into router BGP 605 and do the same command, neighbor 3333 update source loopback 0. And I'm going to do this command, which you'll find yourself doing a lot. Clear IP BGP star, which will clear out the BGP sessions. Sometimes you'll have to do it, sometimes you won't. Most of the time, anytime you make a major change to a router configuration, or as in what filters are going to be used to allow routes through, you'll have to reset your BGP neighbor relationships. So let's do a show IP BGP summary. And we see the status message told all right there, neighbor 2222 is up. So now we have negotiated a neighbor relationship between these two across the WAN link, but does BGP see that? No, it's only seeing the 2222 and 3333 behind that WAN link. So it's really effectively load balancing on there because EIGRP says that we should load balance on there when we're going across those links to those two wide area network addresses. The problem is, okay, we've set up all these BGP neighbor relationships. However, this shows the routing table. As of yet, we have no routes. We have all these peers, but they have nothing to say to each other. So what I want to do is I want to start including some networks in those route updates. Now, there's a few ways that you can do this. And I'm going to bring us back to this live configuration and clear the window. There's a few ways that we can set up networks to be advertised into BGP. The first and the easiest way is through the use of the network commands. Now, the network command in BGP is a lot different than the network command in other routing protocols like EIGRP. We can get under the BGP routing process on router 3, and I've added a few networks behind the scenes. You can see that I've added 3 loopback interfaces, each one with a different network attached to it. Now, I've chosen a IP address or a network from each class of addresses. So I have a class A, the 10 network, class B, the 169.254 network, and class C, a 192.168.33 network. Now, the BGP network command is different and finicky. It drives me nuts. First off, with the standard routing protocol, when we type in network followed by a network, it's going to, number one, activate the routing protocol, as in it's going to send out advertisements on that network, and 2, it will include that network in the updates. With BGP, we don't activate a protocol anywhere. All of our neighbors are formed manually through static configurations. So when we use the network command, the networks that we're typing here are exactly what will be advertised into the BGP routing process. Now, the reason I say it's finicky is because you need to have the exact mask. I can't emphasize this enough. If on router 3 we had 10 networks all over the place, we'll say 10.5, 10.6, 10.7, all these 10 networks all over the place, it's tempting because other routing protocols do this to just type in 10.0.0.0. But for BGP, what that means is advertise exactly the 10 network. As in, if there's an interface on your router that has the 10 network with a class A subnet mask on it, advertise that. If not, then don't. If you're doing any type of custom subnetting, no matter how small it seems, for instance, we put a class C subnet mask on a class A address, so we are doing subnetting here. We have to type in 10.5.1.0. Is that what I typed in there? Yep, 10.5.1.0 followed by a mask and what the exact subnet mask is going to be. We typed in 255.255.255.0 since we are doing that custom subnetting scheme. Now I'm going to have to do that for each and every one of those networks. You might say, well, when do you leave that subnet mask off and just hit enter at that point? Well, the only time it's safe to do that is if you are using the standard subnet mask. For instance, excuse me, this loopback 3 right here. I could type in network 169.254.0.0, enter, and leave it at default because I'm using a default mask, a 16-bit mask on there. But anytime you have something that goes beyond the default, you have to type in the custom subnet that is going to be on there. Again, I can type it without the mask here because I'm using the default subnet mask. It's a Class C address. Nothing has changed. We have to use the mask, and I emphasize this because I've fallen into this trap so many times. We have to use the mask keyword anytime we are doing any sort of custom subnetting, no matter how simple it may seem. At this point, we should be able to go back and verify that those routes have been added to the BGP routing table. I'm going to do a show IP BGP, and we see on router 3, we now have routes in the routing table. And I want to dissect this table real quick with you because this is between the show IP BGP and show IP BGP summary, both great commands to make aliases for. You get a ton of info about BGP in a concise format. In this one, we have the routes, and the first thing we see is some keys up here. You see star means it's a valid route, and the little caret right next to that means that it's the best route that it has. If you're getting multiple routes from or multiple routes to the same destination from maybe different sources, it will have to choose one best route that it puts into the routing table. When we type in show IP BGP, we are seeing the entire BGP routing table, I should say topology table, because only the best of the best end up in the routing table, and I'll show you that in a moment. Let's first dissect this. We see network, and this is the only one that has a slash notation on it because it's the only one that's using custom subnetting. 10.5.1. It's a Class C subnet now. Next top is us. It's all zeros because we haven't changed anything. It's directly on our router. These across the top are all of the attributes that I was talking about in the previous nuggets, understanding BGP attributes. This is the metric, one of the optional attributes that we can set to help a neighbor figure out the best way into our system. Local preference is blank by default. There is no local preference. The weight on everything that is originated at this local router is always 32768 by default. And that is only local to this router. We'll see that on some other routers. And then the path is one of the most interesting one to follow. This shows where this route has been through and come from. Now, it hasn't been far because it originated on our router. So it says the path is I for internal. That means that this came from some internal sort of advertisement, which was done using the network command. Now, if I jump on over to router 2 and do a show IP BGP, it should be receiving these routes. You see them, same routes, but now look at the path. The path 777 is the autonomous system that we just came from. These routes came from here, got advertised to router 2, so now they went through 777 and then were internal to that system. If we had autonomous systems upon autonomous systems traveling throughout the rest of this network, you would see that path grow larger and larger and larger. Notice the weight also went down to 0 because this is only locally significant. Now I want to show you router 1 because we see something interesting. Well, wait, before I get there, I'm going to do a show IP route. And what we'll see is these BGP routes are starting to end up in the routing table. Hurrah! We can now reach these different routes and ping them through our router. The BGP topology table, which is all the BGP routes, are shown using show IP BGP. But the routing table will only have the best of those routes. Now let me go up to router 1 and do a show IP route. Uh-oh. Is something broken here? I mean, look at this. We only have a connected route. Now, I know we're running BGP. As a matter of fact, let me do a show IP BGP and see if we're getting those routes. Look at this. We are getting those routes, but they're not ending up in the routing table. What's the story? Well, we seem to be missing one of our little symbols. We are missing the little caret. It says it's a valid route, but it's not the best route. So what does that mean? It means the rule of synchronization has gotten in the way. You might remember from the first BGP nuggets, BGP theory, there's two rules that really cause chaos in networks, and the first of those is the BGP synchronization. What it says is that in order for these routes to be believed, or any route that's learned via IBGP, it must be backed up by some sort of internal routing protocol. For example, maybe we have RIP running in this network. Well, RIP would have to learn about these and advertise these before they would be believed from IBGP. It's one of the ways that we can prevent black holes in our system. Again, for more info on that rule, check out the BGP theory nugget. In this case, we get into the BGP routing process. In this case, since all of our routers are running BGP and we do have an IBGP session going between these guys, it is safe to do this. No synchronization. That turns off that rule, totally disables it. So now when I do a show IP BGP, I might need to clear the IP BGP process. It's a common thing you'll have to do. Once I clear that and reform that neighbor relationship, these routes should come up as best routes, because now it will say, you know what, throw the synchronization rule out the window. I'm going to believe them because they are coming from BGP and it's a reliable source. Let me see if we've gotten them back yet. See, I told you BGP is slow. So let me pause the recording, give it some time to reform that neighbor relationship, and then we'll check it out. Okay, that neighbor relationship has come back up. I'm going to do a show IP BGP summary, and you'll be able to see right there's our neighbor relationship. We're good and running. Now I'm going to do a show IP BGP, and those routes should now be considered best routes so that it can be used in the BGP routing table. Oh, take a look at that. They're not. Well, my friends, what better way to do some troubleshooting than to actually set this up? I want to show you a debug command. And first off, let me do a clear IP BGP star. Wipe out that neighbor relationship. And I'm going to do a debug IP BGP, and I want to do updates. You can see a lot of different debugs that we have available to us. If you're having trouble forming neighbor relationships, a lot of times it's good to debug the events, because this shows you the overall events that are taking place with BGP. If you have formed the neighbor relationship and you just want to see kind of what routes are being sent and received and just all the updates that are taking place, then that updates keyword that I just typed in is great. And it looks like we just formed that neighbor relationship right up here, and now we're seeing the updates. I'll do a UALT to turn off the debugging. Let's look at this and dissect it. It says BGP received update with attribute next hop 3333. So all the routes are coming in with the next hop of 3.3.3.3. Something to keep mental track of. And we see all the routes. It says I received this route, that route, and the other route. And then it says right here, look at this, no valid path for each one of those routes. So it ends up saying, you know what? I got the routes, I see them, but I have no valid path for. And you know the most common reason why is because it's coming in with a next hop address that's not reachable. Check this out. I do a show IP route, and it's looking at the routing table. Does this router have any idea how to reach the next hop of 3.3.3.3? No way. Look at that routing table. It only knows how to get to its directly connected network. So what it's saying, and it's trying to tell you in this update messages, is I see the networks, but I can't get to the router that's advertising itself as next hop. Now this brings back to the rule that we talked about in the BGP theory section. When the eBGP relationships replicate, the next hop always changes. So this one will change if it was some next hop over here and it advertised into here, it will change and become the next hop of 3333. But when router 2 sends it to an IBGP relationship, it does not change the next hop by default, because in this case, it's trying to save it some resources. It thinks maybe router 1 can get to router 3. Maybe there's some kind of, direct Ethernet connection that gets it there. It doesn't know. So maybe router 1 can reach it, and you don't need to go through router 2 as the next hop. But in this case, we do. And it's causing a problem, so let's fix it. I'm going to go into router 2, router BGP 605, and I'm going to type in neighbor 172.16.12.1, that's our neighbor, and there's one command that we need to type. It is next hop self. Enter. And I'm going to go ahead and clear that BGP relationship because we've changed some attributes on there. It's just a good habit to get into. This will now set itself, it will say, router 2, I am now the next hop for any advertisements that I send to router 1. So when router 1 gets those, and let me jump on over to router 1. Let me just make sure that hasn't come back up so soon. Okay, well, it looks like it just came up 6 seconds ago. Let's do a show IP BGP. Oh, it hasn't received the routes yet. So it's just now forming the neighbor relationship. Give it a second to receive those routes. Oh, beautiful. Look at this. We have all the routes. We have the little best symbol sitting by there, and now we have the right next hop. Wow, I should have clued in on that before. On my scroll buffer does. Oh, it goes right here. Look at this. Next hop, right there, 3333. That's a quick clue. Look at that. See if it's reachable anytime you're not seeing the best route showing up there. And at this point on router 1, I can now do a show IP route. And sure enough, look at that. We now have our BGP networks, and they are now showing up in the routing table as reachable. So in this nugget, we have taken a look at the foundations of BGP, getting it up and running, setting it up, and advertising networks into it. We started off by looking at the pre-thoughts primarily on making sure your router still runs after you start the BGP routing process, because it does consume a lot of resources. We then got into configuring and troubleshooting the BGP relationships, a little more on the troubleshooting side than I thought. However, I think it was an awesome learning process to not only see some of the hiccups that you can run into when you're forming those neighbor relationships, but also when you're advertising those networks, just like we saw, sometimes they may not show up as good networks because some sort of attribute in the middle got tweaked, and now your router can't reach those networks. And we also, of course, as we went through, did the plethora of show commands and debug commands to really start working with BGP. Now, there are many more ways than just using the network command to get networks into BGP. And as we get into the more advanced nuggets on BGP and we look at some of the new strategies for BGP, we'll talk about getting redistributed networks into there and also looking at the origin attribute and what effect that may cause. But I hope this nugget has been enjoyable for you, and I'd like to thank you for viewing.